Okay, I hope you're having as much fun as I am, and I am ready for example 3. Nothing crazy different here. This is just another good chance to practice some algebra. One's going to get a little bit more complicated, so in terms of can I get the right answer so that my math lab accepts it and I don't have to redo the problem 10 million times. So I'd recommend you follow along or try it on your own. I'm going to go a little bit faster this time because you guys are getting the idea of it. So take the derivative of both sides with respect to x, and let's see what we get. So on the left-hand side, I'm going to get 2y times, well, I was going to move faster, but I'm going to get my stupid colors, times dy dx is equal to, on the right-hand side, again, I do not have a product here, good thing, so I've just got two functions that are being subtracted, so I can take the derivative of both separately. I've got a power rule, so I've got 14x, and then I've got minus 10, no dy dx over there. So not too bad. To solve for my dy dx, I'm just going to do a simple divide by 2y on both sides, and I'm going to get dy dx is equal to 14x minus 10 over 2y. And I know I said in, I believe, the last video, example 2, that if you could simplify your derivative, your first derivative, then you should probably do so because we're going to use that. And I didn't actually notice this, but having worked through the problem without doing it, I'm going to highly recommend that if you can simplify it, simplify it. And in this case, we should be seeing that we can divide all the terms by 2. And let's go ahead and do that. Let's rewrite our derivative as 7x minus 5 over y. And if you didn't see that, that would just require some simplifying at the end. But if you see that, we can get rid of that middle, and that's my dy dx. Okay, so proceeding from there, let's see, I'm now going to have derivative with respect to x of dy dx on the left side equal to my 7x minus 5 over y, and I'm taking the derivative, oh, come on, derivative with respect to x of the right side as well. So I've rewritten my first derivative, and I'm taking the derivative of both sides. Similar to the last one, we should be recognizing that we have a quotient rule there. So we're going to have to apply our quotient rule. No big deal. So we're going to have second derivative, d2y over dx squared, equal to quotient rule. So we're going to start with our denominator times derivative of the numerator, d dx of 7x minus 5. So I'm trying to write too small here with my iPad. Minus numerator 7x minus 5 times derivative with respect to x of my denominator, which is y. Give myself a little bit of room here. And all over my denominator squared y squared. So let's go ahead and take the derivatives where we need to take the derivatives. So derivative of with respect to x of 7x minus 5. Should be getting just 7 for that part. So I've got y times 7 minus 7x minus 5. And then over here, my derivative with respect to x of y. Derivative of y is just 1. But I'm going to have to follow that times dy dx. All over y squared. And that is my second derivative. So I'm essentially done with the calculus part, but we need to do some substitution and then, of course, some algebraic simplification. So I'm going to go ahead up to here and recognize that my first derivative is 7x minus 5 over y. So hopefully you can still see yours. 7x minus 5 over y is going to go in place of that. So I'm going to rewrite 7y minus quantity 7x minus 5 times derivative 7x minus 5 over y all over y squared. And like I said before, I'm going to go ahead and try to simplify the numerator first and then take care of the denominator. So if that denominator is bugging you, just kind of ignore it for now. Let's simplify our numerator. So to simplify my numerator, I'm recognizing that I have a subtraction sign, two parts. The right-hand side, I've got a denominator of y. I can really put those together in the top and say I have two things multiplied together all over y. So let's get a y in my denominator on the left-hand side multiplied by y over y. So that's going to allow me to rewrite. I think I should be able to group things, I'm pretty sure, on here, but for now let's just keep shoving it to the top and somebody can show me how to do that tomorrow. Okay, so we've got second derivative is 7y squared minus, I'm going to go ahead and write 7x minus 5 quantity squared, because I'm noticing I have 7x minus 5 times 7x minus 5, all over a denominator of y, common denominator now, and then that is all over y squared. So at this point, I'm now ready to get rid of my denominator of my complex fraction. I'm going to multiply times 1 over y squared to get that to cancel out, and then of course I have to do the same thing in the numerator. So denominators are gone, and we'll keep pushing that up. So I think I just need one more line here. Let's see if we can get it in here. I've got 7y squared minus quantity 7x minus 5 squared all over y times y squared y cubed. And as I said in the beginning, or partway through when we had gotten our first derivative, if you had not simplified your first derivative, you would have needed to simplify at this point. I had gotten something like 28y squared minus the quantity 14x minus 10 squared all over 4y cubed. Simplified, fine, but I think it was easier to simplify when we got our first derivative. So I'm going to follow my own advice of simplify your first derivative and then go ahead and get your second derivative.